Now let's look at sed, the stream editor, which allows us to parse text files in search of strings that are of interest. So whereas grep searches lines for matches, awk searches lines for fields that match, sed searches the entire stream for characters that match anywhere they match, and allows you to perform transformations on those characters, such as changing the case or the characters from one thing to another, depending on what that other thing is that you supply. So it's an important tool that's used in conjunction with grep and awk, and that's sed, or stream editor. Again, this is another old Unix Linux tool. And features include stream editing, which basically means the ability to manipulate text in the stream of the text. So manipulate text at any point, as opposed to doing basic searches for matches on lines or fields using grep and awk, respectively. Now, there are two ways in which you may use sed. You can run it with a reference to a file which contains your instructions, or you may specify the instructions on the command line. So let's just note, instructions may be specified on command line or via file. And the instructions, of course, include the transformations, matches, and so on. So let's take a look at some ways in which you may use this utility. Now we're going to just print some simple items from our grep.test.txt file. We should also note that sed supports the same regular expressions as grep and awk. So supports POSIX regular expressions, which means it's compliant with grep and awk. So the same are supported. In fact, awk and sed are very close tools. So basically, the meta characters and so on that you specify in awk can be used in sed verbatim without any changes. Let's take a look at printing content from our grep.test.txt. Now, sed, when used with instructions such as the following, 1p will print the first line from a text file, or from standard in, or from a pipe. Our file is grep.test.txt. So the instruction is an address instruction which tells it to print the first line. The address is 1, p is print. So prints the first line of the file. Or, of course, if no file is supplied, standard in, which means you could dump content to standard in and sed would print just the first line. Let's see what happens when we instruct sed to do this against our grep.test.txt file. So indeed, it's printed the first line. Now let's confirm that that's in case, or that is the case, and indeed. So Linux is the first line. That means, of course, we can alter the output to print, let's say, the second line, and the third, and so on. So you can print whatever you'd like. Now, how about printing the last line? It's often important to know how to print the first and the last, like using head and tail, respectively. So, print is still the command, but if you recall, there's a meta character which means last. It's a $ symbol. This prints the last line. So this is a token or a character that's reserved to mean print the last line, or reference the last item. In the case of P, it means to print. So prints the first line, set n to P, grep test text, prints the second line, and set n $pre grep.test.txt prints the last line of the file. And that's usage of the $ symbol as a shortcut for referencing the last line. Of course, that means you can print a range of lines. So, set n, and supposing we know the file contains, well, it's now 15 lines. So supposing we wanted lines 4 through maybe 13. So that range can be indicated on the command line by simply indicating 4, comma, 13. But you should always include an instruction, and that's P to print, because sed not only prints, it allows you to delete and transform. So if you use D, for example, you can delete. But we're interested initially in just printing. So P is the instruction that's of interest to us. So grep.test.text. So prints lines 4 through 13 of the file. Let's copy and paste this in, give it a whirl, and see how it works. So indeed, lines 4 through 13, of course. The confirmation of this is to use gedit to see if line 4 is Linux 2011, and test Linux CBT is line 13. So Linux 2011, line 4, as indicated by gedit, and let's find line 13, that is, test Linux CBT. So indeed, that's been returned. And notice that the text has not been transformed. Now this is very rudimentary usage of sed to be able to print content from a file. Very important, however. Let's say you know a file contains n number of lines. You can extract just those lines that are of interest using sed. If, of course, you know the lines that are of interest. Let's say lines 30,000 through 35,000. Sed is a tool for you. Definitely will extract those lines. Now, of course, more can be done. Supposing we wanted to specify which lines are to match. Well, there are many more matching characters and combinations that we may include. For example, we've been printing. Now, supposing we wanted to print all lines but certain lines, for example. All lines but line number 1, as an example. That comes to mind. So sed n, and we want, let's say, everything but line 1. So 1 negation print is the way you instruct sed to not print the first file. So prints all but line 1. Let's see what happens in this case. So sed n 1 not print. That means print all but 1. Now we know line number 1 contains Linux. Notice that it started or output Red Hat Linux. So it omitted line number 1. And you could do the same for a range as well. 1 comma, so let's say 1 comma 3, so all but 1 comma 3. Let's take this whole line and copy and paste it and mark it up to reflect the exclusion of a range of lines. So 1 comma 3 will be omitted, for example. So prints all but lines 1 through 3. And we'll just mark up the command line. And we know lines 2 and 3 include Red Hat Linux in various cases. So this should omit those 2 lines as well. And indeed, it's moved us to the line below the lowercase Red Hat Linux. So that's a way to omit a range of lines. Just indicate the ranges separated by a comma, and that will do the trick. Now, you may also specify patterns using regular expressions, characters, /, for example, the standard delimiters for regular expressions. So let's take a look at that. Now we are sending instructions, so we'll use the E option. And in between single quotes, we'll specify the regular expression and that it's to be printed. So supposing we wanted to print lines containing 2011. Since 3 lines or 4 lines ostensibly contain 2011, this will allow us to do an awk-like extraction. So now, we use the E option whenever we send instructions. And when we send instructions, we place those instructions between single quotes. And since this is a regular expressions match, albeit a simple one, the regular expression is placed between the /. Those are the delimiters. The trailing P instructs sed to print the matches. So grep.test.text, and prints lines containing 2011 without any regard for whether or not 2011 begins or ends the line. So let's try this from the shell to see how it plays out. And there are lines containing 2011. One begins, two end, one contains it in the middle. So how does that impact our regexes, such as show me lines terminating with 2011? Well, indeed, $ is honored as expected. How about lines beginning with 2011? Well, caret symbol does that trick. There's the lone line beginning with 2011. How about lines that begin and end with 2011? Well, we don't suppose we have such a line, but nonetheless, we can still search for it. Now, from SED's perspective, it executed successfully, so the exit status returned cleanly. Let's mark this up to show that the regexes are accepted just as we've mentioned them with respect to grep and awk. So 7, 8, and 9. So in one instance, show me lines that end with 2011. Print lines ending with 2011, or ending in 2011, or with. Let's go with. Sounds grammatically better. And show me lines beginning with 2011. And of course, show me lines that begin and end with 2011, which means leading caret, trailing $ symbol. These meta characters, these anchor characters, are the same across grep, sed, awk, Perl, and for that matter, most if not all regular expressions utilities. So lines starting and ending with 2011, for which there are none, which means we can mark up our data to see whether or not it will work. And here's a line beginning and ending with 2011, so it will now appear in our grep dump. When we search it, let's take a look. Make sure that our file is saved. And there must be an additional character, so let's just alter this to include 2011. That gets both, but to get the one that's of interest, ** terminating, and it gets both of them. Let's go with simply **, and it picks both of them as well. So there's a character at the end of it, which is why it doesn't terminate. But nonetheless, interspersing ** does a trick to pick up that line, which begins with it and ends with it, but it also picks up the other line, which contains it. Let's see if it's a space that's at the end of the line, and it's actually not. It's some other character, non-printing, of course, that's in the way. Actually, it's multiple characters, so let's try to clean this up and see how it comes out. Now, that's the only one with a space. This one contains both. And let's drop it. Now finally it gets it. So it's because of the spaces. We introduced multiple spaces inadvertently, resulting in it not being able to find the line. So that works. So you can pick up lines starting and ending with using caret and $, and lines starting with, ending with using either of those meta characters respectively. Now again, there are a number of other things you may do. You can use character classes, for example. So you can, let's say, look for lines that contain numbers, which is often important depending on your data set. So sed NE, and we are searching, let's say, for lines just containing not a full regex, but let's say 0 through 9, meaning numbers. And this will search just for lines containing numbers. So prints lines containing numbers without regard for their placement, meaning beginning or ending the line. Of course, we can mark it up to reflect whether or not it should begin or end the line end. We need to terminate now. If we don't specify a file, it'll throw an error. And let's go ahead and specify grep test text, and let's just double check our syntax here to see what it doesn't like. And it's actually missing our regex match for 0 through 9. And if it throws an error still, it's the escape issue. So let's go ahead and double check that. Now we're missing the print, so it's actually, the escape seems to be fine. It's the print. It says it's missing a command. So let's try to print, and that's more like it. So the print was missing, and we needed our regular expressions characters to indicate that what's between is a regular expression as simple as it is a simple character class. So / but sometimes on some platforms you'll see errors surrounding various characters like parentheses and square brackets and otherwise, which means you'll have to escape with a \. P to print, that's the command that has to be sent. Patterns commands, just like with awk. So this prints lines containing numbers, and if there are lines that begin with numbers, so for example, let's clear screen and rerun this command. Any of them beginning with numbers can be preceded with the character class with a character, and it'll include it. Of course, if it begins and end with numbers, then terminate with a $, and that'll search for it again. That assumes no space, but in this case, it's searching for just one number as opposed to two. Oops, this is an error here with the parentheses. Instead of 2 or more, in our case 4, so $. So that searches for $, and it picks that up. So this gets us more than one character, but also the $* will pick up non-printing white space as well as alpha characters such as Linux CBT. So to rule this out, you could put the number of numbers, or you can just repeat the character class n number of times. So 0 through 9, 2 more times will get us just those 4 characters precisely. So let's close this out, and that's a third instance, 0 through 9. And that should terminate the line, so that picks it up as well. So this is another way in which you may search for 4 characters, or you can specify curly braces 4 to indicate that there should be 4 items. So let's include this as well. That is said, and we want to print, and that's the wrong paste. Let's get that again. It should be Control-Shift-C to get this whole block. Let's put this into memory and try to paste it into our notes. That's more like it. So prints lines containing 4 juxtaposed numbers. They must be juxtaposed, otherwise this regular expression will fail. Let's show you that variation on 4 character class juxtaposed numbers. So sed NE, and instead of indicating the character class 4 times, supposing we want to find a line that has 4 numbers beginning and ending the line. So caret index to start the line, character class 0 through 9. And then instead of repeating this 3 more times, we simply include curly braces to indicate the number of times that the preceding match is to occur. However, this will be misinterpreted by the shell, so we'll have to fix it. Let's include the / to indicate that this is a regular expression string that's POSIX compliant with a print option from grep.test.text. But this will throw an error, but let's show you what error is returned anyway. And then we'll correct it using the escape sequence. Now it doesn't appear to be much. However, notice no values were returned. So the search was unsuccessful, and we know that there are items that contain 4. Now let's break this out with the proper escape. So, and this was beginning the line, so we'll escape this curly brace and this curly brace, and notice now we get values. So some shells will return errors, others will simply return nothing. And now when we escape the curly brace, we see that there are indeed results. In this case, 2 lines were returned because the search is looking for 4 juxtaposed numbers, and both lines that start lines because of the caret, and both lines contained 4 juxtaposed numbers that start lines. To extract the 4 juxtaposed numbers that start and end the line, then you have to terminate this whole search with a $, and that does the trick. So that's where escaping of certain meta characters will become important if you experience undesired results. So returns lines containing 4 juxtapose numbers that begin and end the line. And of course we can extend our content to reflect this phenomenon. So 2012, 2013, 2010, we'll include those, and let's include 2010 Linux CBT. This line will not be included as a consequence, and any series of numbers that fall within 0 through 9 will match this pattern. So there we see 2011, 12, 13, and 10. And of course, these items can be piped into a utility like sort, so that 10 comes before 11, before 12, before 13. Sort is another utility which sorts for you alphabetically, ascending and numerically ascending, 0 through 9. So that's how you perform that type of set query. Again, so far we've been printing, and in this case we've executed some simple instructions which include to print the content. But of course, set excels at changing or substituting content. That's where it becomes much, much more powerful. It can also be used to search for whole words and a number of words or ranges of words, for example. So you can return all lines, for example, or all strings between 2 strings. For example, you can return all strings between, let's say, red and Linux, which will include hat. Let's take a look. So 1.4, that's going to be set NE, and this one looks a little bit trickier when we construct it, but it's not. So we want lines that begin with, let's go with red, and comma, another query string. We also want them to end with Linux, and we want everything in between. So let's see how this performs from grep.test.text. And this is a way of extracting a range of characters. Matches all lines from one to the other. So it'll get all those lines from the one containing red to the one containing Linux. Let's see how this plays out. And notice, starting with red, it's gotten this line, hat plus Linux, then Red Hat Linux, then Linux 2011, leading up to the next string that contains Linux, which is this one here. So you're able to extract a range of lines. So extracts a range of lines from string red, beginning the line. So let's just include that it's a string that indexes or starts the line to, in this case we specified upper L, lower I, and UX. So you can extract a range of lines using a comma delimiter with the various regular expressions. And you can also add lines, so you can extract a range and then include a number of lines after, or you can extract a particular line and get n number of lines after it to see what's around it, which grep supports, for example. So, for example, set NE. Perhaps I want to see the line that is indexed with red between irregular expressions search, which is very important. And I'd like to see 2 additional lines printed after. So we've been using just P all along, which means print whatever is matched, but now we're saying +2, so print 2 more lines. So grep test text extracts line with red and 2 others, 2 lines that follow the one that contain the string red. So let's try this out, see how it works, and let's just double check our string to see we didn't close out the regular expression after the search, and that's comma plus 2p. Let's just double check the index and E, and actually no, it's the file name. So it's the regex is fine, file name is wrong. So there is the line that's indexed with red, upper R, and 2 other lines. Let's alter this to include the line that begins with lower R, and then it gets the 2 lines after that. So that's a way to extract lines in succession. And let's fix our file name, grep.test.text, so that it reflects as follows. You may also delete lines. Instead of using P, simply reference D as we mentioned earlier to delete lines that are of interest. You can delete the output to standard out or delete in place in a line. Now, one of the common things that administrators and engineers of Linux are often tasked with deleting are blank lines. There's a way to search for blank lines, so let's take a look. That will be SED, and this time notice no N option. And we want to search for lines that begin with and end with nothing, or in other words, white space. And when we find those lines, we'd like to have those lines deleted from grep.test.text. Now, the file will not be updated in place to guard against data corruption. So this deletes blank lines. But you can store the output using standard out redirection or using the in-place option, which will overwrite the existing file, and with the optional backup. So SED can make a backup for you of the original file in the event that you've corrupted your data. Now let's see if this file contains any blank lines that are worth. And let's see what SED does with it anyway. So there are no blank lines. Now let's introduce some blank lines into the content. So between, let's say, each of the years below, we'll include some blank lines. And now we've got blank lines in the content that need to be cleaned up. And now notice when we run it through that the blank lines have been removed. So the way to reference blank lines is to use $$ as a regular expression search. And of course, the source file is never updated unless you indicate explicitly, but you can preserve the output by using redirection. So for example, sending the output to grep test text, for example, 2, and now looking at grep test text 2, you'll see that it no longer contains those blank lines. That's perhaps a safe way to use SED in conjunction with delete options. So 17 is the same command, but using output redirection. So sending this to grep.test.text2 deletes blank lines and saves results to the new file name. That's perhaps a safe way to go about it so you don't clobber the contents of the source file. But if you're absolutely certain, then SED also supports the ability to overwrite the original content. And if you scroll up, you'll see the in-place option. The I option allows you, and if you specify a suffix such as BAK for backup, then it'll edit the file in place and make a backup of that file. So, for example, instead of going to output, we could instruct SED using the in-place option with a suffix of BAK, for example, to back up the original file. And let's echo the exit status, LSLTR, and now we will see the back. It doesn't include the dot. And if we cat the contents of grep test text back, you'll see that it has spaces, and the new grep test text contains no spaces. So the in-place option is the option you'll want to reference. Let's just note that SED, in this case, E, no N, and we're searching for spaces or white spaces that make up a line or empty lines. And it's from grep.test.text, and instead of output redirection, we want the in-place option, and let's just include that as .bak. And let's just note, deletes blank lines in place and archives original or source file. And let's just tack on the .bak too. But in fact, the file's now been preserved. So let's move grep test text back to grep test text and then rerun our command, our SED command, using .bak. And then let's use a little command chaining, followed by the echo of the exit status, followed by ls ltr grep.test star. And there we see the new dot back. And if we cat the contents of grep test text, contains no spaces. We could also use SED to search for spaces to see if they exist, to print them if they exist, by searching for $, and then printing it if it exists. as opposed to deleting it if it exists. So that's another way in which you may execute sed. Another thing you can do with sed is to search and replace. So you can search for content and replace it. Let's reload this because gedit noticed that the file has changed. Now let's say wherever 2010 exists, it should become 2011. Search and replaces the option for you using the S option. So let's go ahead and sed, and we want to send some instructions. Search and replace. So search for 2010. And wherever you find 2010, make it 2011. This will do the trick. You can also print it from grep.test.text. Very simple way to execute sed, but it's perhaps the most useful way in which you may use sed to transform data. And of course the output goes to standard out. So let's see what happens when we attempt to search and replace. Now it prints. Now let's cat the contents of grep test text again. And notice that it changed these two results on standard out. And it printed just those results. So there we see. Let's drop the N option. And now it shows everything. Now just a quick word about the N option. The N option, when it's in place, if you notice, suppress the output of non-matching lines. When it's not there, the non-matching lines are printed, and of course matching lines are also printed. So the N is to suppress the matching or the non-matching lines, showing only the matching lines. So let's just note that -N suppresses non-matching lines. But there are times when you want to see the output with non-matching lines in the event that you intend to use output redirection, which is why we dropped the N option recently with respect to the output redirection in this case, for example, because we wanted to show non-matching lines. Or in this example where we didn't write to a new file but wanted to see on standard out the non-matching lines plus the matching lines. In other words, the new cleaned content or the new version of the content. So sed is your ultimate search and replace utility. You can search for content, replace content. You can search and replace using regular expressions. It's left regular expression and replacement character or characters on the right. There's much more you can do with sed. Again, for more details, consult Linux CBT awk sed edition where we go into deeper details of how you may use both awk as well as sed. So that's a little bit of an introduction into the world of the stream editor sed.